And now let's look at how we solve radical equations. The first thing we want to do is isolate the radical. So this is the radical. We want to isolate it. We want to get it by itself. So I'm going to add 3 to both sides. As you can see on the left, that is not a like term, so those cannot combine. So it'll stay as 2x plus 3, and the right side has now become the square root of 28x plus 29. Now, to get rid of a square root, you square both sides. So I'm going to square this side. Now, to work this out, I'm going to need to FOIL that. So I'll just write here FOIL, but I'll do the foiling over here. So to FOIL that, it would look like first times first, and so I need to write these out so you can see them. We want to go first times first, which is 4x squared. Outside times outside, 2x times 3 is positive 6x. 3 times 2 is positive 6x, and then 3 times 3, which is 9. We can take that down and say this is 4x squared plus, this is now 12x, 6x plus 6x is 12x, plus 9. All that will equal, over here, the square root goes away, and so we have 28x plus 29. To solve this, we're going to combine like terms again. So I'll subtract 29 from both sides, and I'm also going to subtract 28x. Anytime we want to solve an equation and there's a power greater than 1, so it's no longer linear, something greater, you'll solve it by getting one whole side equal to 0. So we have 4x squared. This looks like it's negative 16x, and this becomes minus 20 equals 0. And before I x method this, I see there's a GCF. Since they can all be divided by 4, and since I have it equal 0, all I have to do is divide everything by 4 to simplify. So I'm actually going to try to x method x squared minus 4x minus 5. That needs to equal 0. So we do x method here. I should have wrote on here that this step was a GCF. Okay, so x method, a times c goes on top, which is 1 times negative 5. So factors of negative 5 that add up to negative 4. Well, that would be negative 5 times positive 1. Those would multiply and give me the top while adding to the bottom. I need to divide this by 2, or split it in half. So I'd have x minus 5 times x plus 1 equals 0. It looks like I have two answers, x equals 5 and x equals negative 1 here when you solve. Now here's the deal. Sometimes when you solve these, we will have both answers, and sometimes one will be what's called extraneous, an extra answer. The easiest way to tell is you go back and you graph each one from the get start. So this is F1, this is F2. When we look at the graph here, you'll see that this is to check our answers is what I'm doing here. The F1 is this straight line. The F2 is this bend here, the square root, and it does hit at negative 1 and positive 5. So we did that correctly. Let's try part B. Again, if you wanted to, you could start from the get-go and say that's F1, that's F2, and you could solve this to see what answers you get. But I'm going to work through it doing algebra. So I'll first subtract the 8. That goes away, and so I have 4 equals the third root of x minus 2 quantity squared. Now this is a little bit trickier to get rid of. What we need to do is to get rid of a third root, you need to know how you can rewrite that, and that would be rewritten as x minus 2 to the power of 2/3. So how do you get rid of something to the power of 2/3? You raise it to the 3/2. So I'm going to raise this all to the 3/2. But anytime you take a square root, which technically raising something to 3/2 is taking the square root, you're going to have plus or minus over here. It's just a rule of math. So this part cancels out. So I'm left with x minus 2 equals 4 times the plus or minus. Now the square root of 4 is 2, and 2 cubed is 8. And you could have just typed that in the calculator. So plus or minus 8 equals x, which means when you add the 2 over, and we add the 2 over here, we'll have that x is going to either equal, when you add, you'll have 10, or If it were negative 8, 2 plus negative 8 would be negative 6. These would be our solutions. Now let's check and see if there's two solutions in the calculator. When we pull that out, we get this, and sure enough, we get those values, negative 6 and 10. Let's try one more. So again, you want to isolate the square root. Now, as you can see here, we have two square roots, so we can't isolate them. So when this happens, you do square from the get-go, but you have to square the whole side. Now, the left, that's easy to understand. The right is where it gets tricky. You've got to square all this, which means we're going to have to do a FOIL with a square root. So imagine your worst nightmare, double it, and yeah, that's what we're doing. It's kind of a joke, but kind of not. When you square, or when you FOIL out this, we'd have 1 times 1 for first, and that's a 1, plus 1 times that square root, which means we have that square root. Then we had that square root times 1, so again we have that square root. So we have 2 of those square roots, and then the square root times itself gives you just the insides of that root. So that's the values there. We can go to simplify that. The left simplifies real easy, is x plus 1. That would equal, I'm going to combine some like terms here. I'll have the 2x out front, 2x, and then I also have this 1 minus 12, which means minus 11 there. And then I have 2 of these square roots. So I'll do plus 2 times the square root of 2x minus 12. I told you this is not going to be that fun. Now, let's simplify. I'm going to try to get the square root by itself to solve for it. So I'm going to subtract 2x from both sides. And I'm also going to add the 11 here to both sides. So now, that goes away. But I now have negative x plus 12 equals 2 times this square root. And before we square to get rid of that, I first need to get rid of the 2. All right, so when I square this, or before I square that, I'll move the 2, divide the 2 over. And I'm going to divide each one of these by 2. You got to do it to everything. These are connected. These are considered one factor, so you only have to do it once. These are 2 terms, so you have to divide each one. So now really what I have is negative half x plus 6 equals the square root of 2x minus 12. Let's square. So I square this, and now I square this, and oh, look at this, how fantastic. We get to, again, do a FOIL. So let's do a FOIL one more time here. Sorry, I'm trying to get rid of that. And so I would have negative 1/2 x plus 6 times negative 1/2 x plus 6. For this FOIL, I multiply out. First times first gives me positive 1/4 x squared. Outside times outside is negative 3x. Inside times inside is another negative 3x plus 36. All that equals 2x minus 12. Now, if that wasn't enough, we got to combine some like terms. And in the process, I'm going to subtract 2x over. So all these are going to combine. I'll have negative 1/4 x squared minus 3x more is negative 6x minus 2x more is minus 8x. And then I'm also going to add 12, add 12. That gives me 48. All that equals 0. Wow. Now, we're in an x method. But to get this x method in properly, I'm going to make this a become 1. I can do that by multiplying everything by 4. If I multiply both sides by 4, I should get, and I'm going to take this way up here, I'll have x squared, no, not plus, I'm sorry, minus 32x plus 192 equals 0. And now I can x method, and I'll be done. So factors of 192 that add up to negative 32. Let's see, 8 and 40, no. I believe it's going to be negative 24 and 8. Negative 8, I'm sorry. That would be 61. Yeah, that works for positive, and that works for the negative. Okay, so this factors as x minus 24 and x minus 8 equals 0. So we would think the answers would be 24 and 8. Well, if we plug them in, we'd actually find out that one of them is extraneous. This answer here is extraneous. They would not hit each other again. And so we only have one answer here, and the answer is 8. Again, this other answer would be called extraneous. Now here's one for you to try, and I'd recommend the graphing technique.